whereas 15 and 17. So all the elements which comes under both the set is called as the union of sets. A less than or equal to x less than or equal to b. The value of x lies between a and b, including a and b, is called the closed intervals. The number of elements which are common in x and y, n of x intersection y is 10. That's it. X intersection y is 10. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the sets and the operations on sets, as well as different types of sets and the subsets. Now in this session, I will take few problems on operations on sets, as well as the intervals on the subsets, and some practical problems on this set theory. Okay. Now let me come to the first problem. So if A is equal to 3, 5, 7, 9, 11 and B is equal to 7, 9, 11, 13 and C is equal to 11, 13, 15 and D is equal to 15, 17. Four sets are given, A, B, C, D. And what is required to find? A intersection B union D, A intersection B union C, and here A union D intersection B union C. These three problems are given. Let us come to the first problem. Here A, B, C, D, four sets are given. What is required to find? A intersection B union D, A intersection B and C union. Again the last one is the intersection of A union D and B union C. So here union, intersection are given. Now let me take the first problem. In the first problem, first find out B union D. Now B union D is equal to union of B and D. So what is B contains? B contains 7, 9, 11 and 13. Union of D. What is D contains? D contains 15 and 17. So the union of these two common elements, as you know, the union is nothing but all the elements in both the sets. So 7, 9, 11, I will write 7, 9, 11, 13 and whereas 15 and 17. So all the elements which comes under both the set is called as the union of sets. Now let us write, what is to find is A intersection B union D. B union D. Now here let me write A first. What is A contains? A contains 3, 5, 7, 9, 11. The intersection of B union D. B union D intersection is 7, 9, 11, 13, 15 and 17. Now the intersection is nothing but the common elements in this. So what are the common elements we will have in both the sets? So here 3 is not, 5 is not there, 7 is there, 7, 9, 11. So here 13, 15 is 17 is there in second set, but we don't have in the second set. So these are the intersections. So therefore A intersection B union D is equal to 7, 9 and 11. These are the intersection. That is the first answer. Okay. Very simple. See here. First write on B. What is B? B contains 7, 9, 11, 13 and union of D. What is D? D is 15 and 17. Now the union of these two, is 7, 9, 11, 13, 15 and 7. All the elements in both the sets. Now the intersection of this, A intersection B union D. Write down the elements of A. A contains 3, 5, 7, 9, 11. Intersection this 7, 9, 11, 13, 15 and 17. The union of the intersection is nothing but the common elements in both the sets. So 3 is not in the second set, 5 is also not there, 7, 9, 11 are included in both the sets. So therefore the intersection is 7, 9 and 11. Now let us come to the second problem. What is the second problem? A intersection B union C. Let us write down the first part, A intersection B. So for the second one, write down A intersection B. Intersection B is nothing but the common in A and B. The common in A and B is so 7, 9 and 11. These three elements are common in both. So A intersection B 7, 9 and 11. Now the second part is B union C. union of B and C. So the union of these two. So B contains 7, 9, 11, 13, 7, 9, 11, 13 and 7, 9, 11, 13. Here 11 is also there, 13 except 15, I can write 15. Now what is to find? The intersection. So therefore A intersection B intersection B union C. So the intersection of these two. What are the intersection of these two? The common element 7 is there, 9 is also there, 11 is also there. So this is A intersection B union C. The common elements in this. So first write down A intersection B, that is the elements which are common in both A and B, 7, 9, 11. And next second, find out B union C, the union, all the elements of B and C, that is 7, 9, 11, 13 and 15. And the intersection of these two, intersection of A intersection B union C, that is the common element 7, 9, 11, 7, 9, 11 comes under this. And this is the second part. And come to the third one. What is the third problem given? A union D intersection B union C. A union D intersection A union D intersection B union C. Now first find out A union D. Now I'll write here A union D. Union of A and D. A contains 3, 5, 7, 9, 11. So I'll write 3, 5, 7, 9, 11. That is A 3, 5, 7, 9, 11. 3, 5, 7, 9, 11. And D. What is D contains? D contains 15 and 17. So 15 and 17. I will write 15 and 17. That is A union D. Next, B union C. Union of B and C. First write down the elements of B. 7, 9, 11, 13. 7, 9, 11, 13. Then union C. Union of C. C contains 11, 13 and 15. So only the element we have is 15. So I can take 15. Now the intersection of these two. A union D intersection B union C. What is A union D? A union contains 3, 5, 7, 9, 11, 15, 17. Right. Then what is the symbol they have given? Intersection. Intersection of B union C. 7, 9, 11, 13 and 15. Write down the common elements, that's it. So this is equal to common elements are 7, 7 is there. Then 9, 9 is also here, 11, then 15 is there, 15, that's it. So these are the elements. So A union D intersection B union C is 7, 9, 11, 15. This is how we are going to solve the problem. So this type of problems which we have already solved in the previous session. So just for your revision, I took this problem. Now let us come to the next concept, very important concept. Very important concept, that is intervals as subset of R. Intervals as the subset of R. Suppose, let us consider two elements. Let A and B belongs to R. If A and B are any two elements of R, R is nothing but the set of all real numbers. If A and B are any two real numbers, and if A is less than B, then the set of real numbers, set of all real numbers Y such that Y lies between A and B. If A less than Y less than B is called an open interval and it is denoted as A comma B. So small a comma B is the representation of an open interval A comma B. That means all the elements which lies between A and B comes under the open interval. So usually open interval is represented between the two small brackets. So small bracket, all the values which lies between A and B comes under open interval. That is, suppose if X is any element, if X belongs to A comma B, then we can write A less than X less than B is called an open interval. So that is, the values which lies between A and B is called an open interval. That is, all the points between A and B belongs to the open interval A comma B, but A and B themselves do not belong to the interval. So therefore, the open interval A comma B is denoted as X such that A less than x less than b. That means the value of x which lies between a and b comes under open interval. Let us take an example. For example, 3 comma 7. Open interval of 3 comma 7 means what are the values we will get here? 3, 4, 5, 6 and 7. The values which lies between 3 and 7 is 4 comma 7. So that is nothing but 4, 5, 6 comes under this set. That's it. 4, 5 and 6. So 3 comma 7 open interval represents all the elements like 4, 5 and 6. So this is represented as 3 comma 4 is represented 3 less than x less than 7. So all the values of x which lies between 3 and 7 is 4, 5 and 6. This is an example for an open interval. So open interval means all the values which lies between values lies between a and b. Now the second one is called the closed interval. So closed interval, the interval in which contains the endpoints is also called as a closed interval, and it is denoted by the big brackets like this. Big bracket of AB is nothing but the closed interval. So what is closed interval here? All the values of A which lies between A and B, including A and B. So that is denoted as closed interval A comma B is equal to a set X such that A less than or equal to X less than or equal to B. The value of X lies between A and B, including A and B, is called the closed interval. So therefore the closed interval of A comma B is X such that A less than or equal to X less than or equal to B. So this is the closed interval. That means here all the values of A and B, the closed interval of A comma B is nothing but A less than or equal to X less than or equal to B. That means all the values in between A and B, including A and B, comes under the closed interval. Now let us take an example. Closed interval of 2 comma 7. So that means this is denoted as, this is written as 2 less than or equal to X less than or equal to 7. So all the values which lies between 2 and 2, 3, 4, 5, 6 and 7. This is how we are going to represent the elements of closed interval 2 comma 7 means 2 less than or equal to X less than or equal. So suppose if it is like this, 0 less than or equal to X less than or equal to 4 means we are going to represent this as the interval 0 comma 4. This is called the closed interval. So all the values of A and B, including A and B and in between A and B, comes under the closed interval denoted as big bracket A comma B. Small bracket A is nothing but open interval, that is all the values which lies between A and B. Now sometimes they may ask closed and open, off closed and off open, or off open and off closed. That is called semi-closed and semi-open intervals. Now we can also have the intervals closed at one end and open at the other end. So we can have intervals which are open at one end and closed at the another end. So that means interval closed at one end and open at the other end, that is denoted as big bracket of A comma B and small bracket, that is called off closed and off open. That is nothing but X such that A less than or equal to X less than B. Here it is off closed and off open. So A less than or equal to X less than B. That means all the values in between A and B, including A, all the values in between A and B, including A, comes under this, excluding B comes under off closed and off open. So similarly, off open and off closed is denoted as small bracket A and big bracket B is X such that A less than X less than or equal to B. That means all the values which lies between A and B, including B and excluding A, that is open from A to B. So this is nothing but X such that A less than X less than or equal to B is an open interval from A to B, including B but excluding A. So these are called as a semi-open and semi-closed interval. So how to represent this semi-open and semi-closed? Semi-open and semi-closed interval. So off closed and off, semi means off closed and off open interval. So A comma B, here this is nothing but X such that A less than or equal to X less than B. That means all the values of X which lies between A and B, including A but not B, excluding B. Let us consider, for example, let us take an example of closed 2 comma 6. So this is nothing but 2 less than or equal to x less than 6. That means this can be written as 2, 3, 4, 5. That's it. So including 2, excluding 6. So that means 2, 3, 4, 5 comes under this semi-closed and semi-open, off closed and open. Similarly, semi-open and semi-closed, semi-open interval and semi-closed means here it is closed. So A comma B. So that is A comma B is a set X such that X lies between A and B, including B but excluding A. A less than X less than or equal to B comes under a semi-open and semi-closed. That means here all the values of X lies between A and B, including B excluding A. So denoted as, so here A is included, here B is excluded, here A is excluded and B is included. This is how we are going to represent this semi-open and semi-closed. Now let us take for example, one more example. Let me take another example here, 3 comma 7. So 3 comma 7 means this is nothing but all the values between 3 to 7, that is 3, 4, 5, 6, 7. So what are the elements we are going to take? A less than X less than or equal to B. So these elements comes under this. So that is nothing but 3 less than X less than or equal to 7. That is nothing but 4, 5, 6 and 7. 4, 5, 6, 7 comes under this set. This is how we are going to represent the intervals. Closed interval, open interval, semi-closed and semi-open, off-closed and off-open intervals. Now, you got an idea regarding the intervals of a subset. Now, let us come to the intervals as subset can be explained like this. These notation provides an alternative way to design the subset of set of all real numbers. For example, if A is equal to minus 3 comma 5 and B is equal to minus 7 comma 9 is the set. So this is open interval and the closed interval. Suppose if the set of closed and open interval is taken, the set 0 to infinite, define the set of all negative real numbers, while the set minus infinity to 0 will define the set of all negative real numbers. 0 to infinity, 0, 1, 2, 3, etc. Infinite is nothing but set of all negative real numbers, whereas minus infinity to 0 will define the set of all negative real numbers. Now, the set minus infinity comma describes the set of all real numbers in the relation to a line extending from minus infinity to plus infinity. So that is the real numbers in the relation to a line extending from minus infinity to plus infinity is denoted as minus infinity comma plus infinity. So on the real number line, various types of intervals describes as the subsets of Rs. Here A comma B, open interval, the closed interval, off open, off closed and off closed and off open, that is semi open and semi. So we can note that an interval containing infinitely many points. Okay, so this will contains infinitely many points. So this is how we are going to represent a closed interval, open interval, off closed and off open interval. Now by knowing this, let us come to some examples. Now let us take an example. The set X such that X belongs to R, where minus 5 less than X less than or equal to 7, written in the set builder form as minus 5 comma 7. So all the values which lies between minus 5 and 7, excluding minus 5 including 7 is denoted in the set builder form. Similarly, the interval minus 3 comma 5 can also be written in the set builder form as minus 3. Here it is closed, minus 3 less than or equal to X less than 5. So minus 3 less than or equal to X less than or equal to 5 is nothing but minus 3 comma 5. So the number B minus A is called the length of any of the interval A comma B or A comma B or A comma B or A. So B minus A is called the length of the interval A comma B, closed, open or semi-closed or semi-open intervals. Now, by knowing this, let us come to the very important concept, that is the applications of set, practical problems on the union, intersection and complementation of sets. Now the practical applications on the operations on set. Now let us consider two sets. Let A and B be any finite sets, then the intersection of a finite set is a null set. A intersection B is equal to null set means then n of A union B is equal to n of A plus n of B, because intersection here is a null set. So, if A and B are any finite set, if intersection of the two sets A intersection B is equal to null set, then n of A union B is equal to n of A plus n of B. Number of elements in A plus number of elements in B will give the number of elements in A union B. That is known fact. Now, the element in A union B are either in A or in B, but not in both A intersection B, that is a null set. Now, in general, if A and B are finite sets, then we have a formula n of A union B is equal to n of A plus n of B minus n of A intersection B. This is very important formula to solve the problems. So, n of A union B is equal to n of A plus n of B minus n of A intersection B for any two sets A and B. Similarly, if there are three sets A, B, C, for any three sets A, comma B, comma C, then any three non-empty sets, n of A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C. That is n of A plus n of B minus n plus n of C. Number of elements in A plus number of elements in B plus number of elements in C minus, take two elements, the intersection of the two elements, that is minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. So, here n of A plus n of B minus n of A intersection B, whereas here n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C will give the formula for, will give the answer for number of elements which are in A, B and C, n of A union B union C. So, these type of formulas are used to solve the problems in practicals, that is practical application of a problem. Now, let us come to the first problem. If x and y are two sets such that number of elements in x is 17, n of x is 17, number of elements in y is 23 and number of elements in x union y is equal to 38, then find the number of elements in x intersection y. Very simple. So, what is given? Very important type problem for 5 marks. Given that, given number of elements in x, n of x is 17, number of elements in y, n of y is equal to 23 and the number of elements in union, x union y is equal to 38. Now, what is required to find is n of x intersection y. This is the question. Okay, now we have the formula. So, we know that n of x union y is equal to n of x plus n of y minus n of x intersection y. So, this is the formula we are going to use. So, number of elements in x union y is 38 is equal to n of x, number of elements in x is 17, y is 23 minus n of x intersection y. Now, just interchange this. So, n of x intersection y is equal to, add this 23 plus 17. So, this is equal to 40 minus 38. So, that is equal to 2. So, therefore, the number of elements in x intersection y is equal to 2. That's it. So, if you do this much, you will get 5 marks. Very simple problem indeed. Okay. See, listen to me here. So, what is given? The number of elements in x is 17. Number of elements in y is 23. Number of elements in x union y is 38. What is required to find is n of x intersection y. We know that n of x union y is equal to n of x plus n of y minus n of x intersection y. So, 38 is equal to 17 plus 23 minus n of x intersection y. Transfer this n of x intersection y to the left hand side, then 17 plus 23 is 40 minus 38 is 2. So, therefore, number of elements in x intersection y is 2. So, otherwise straight away you can write n of x intersection y is equal to n of x plus n of y minus n of x union y. So, any formula you can use to solve this problem. Okay, hope you followed. Now, let us come to a similar type problem. Now, what is the second problem? Here, if same type problem, x and y are two sets such that x union y has 18 elements, x has 8 elements and y has 15 elements. how many elements does X intersection Y have? Same problem. So they have given, what is given? Given like this, similar type problem, number of elements in X union Y. X union Y is equal to 18, and X has number of elements in X is 8 and Y has number of elements in Y is 15. How many elements in N of X intersection Y? That is to be determined. That's it. This is the given data. Number of elements in X union Y is 18. Number of elements in X is 8. Number of elements in Y is 15. Number of X intersection Y. So we know the formula. Number of X intersection Y is equal to N of X plus N of Y minus N of X union Y. Simplify this. That's it. So number of elements in X is 8, number of elements in Y is 15 minus number of elements in X intersection Y is 18. If you add 15 plus 8, 15 plus 8 is 23. 23 minus 18. 23 minus 18 is nothing but 5. So therefore, the number of elements in X intersection Y is equal to 5. That's it. Straight away we can put the formula N of X intersection Y is equal to N of X plus N of Y minus N of X union Y. N of X is 8, N of Y is 15, 8 plus 15 minus N of X union Y is equal to 18. So that is 23 minus 18 is 5 is the required answer. Okay, hope you followed. Okay, now let us come to the next problem. So if X and Y are two sets such that same type problem, X intersection Y has 50 elements, X has 28 elements and Y has 32 elements. How many elements does X intersection Y have? Same type problem. What is given? Now given that, so X and Y have two sets, X union Y. X union Y is equal to 50. That means number of elements in X union Y is 50. 50 elements. Then X has number of elements in X. X has 28 elements. Y has number of elements in Y is 32 elements. Then how many elements does X intersection, the common X intersection Y is equal to question mark. Now, so we know the formula N of X intersection Y is equal to N of X plus N of Y minus N of X union Y. Substitute, that's it. So N of X intersection Y is equal to N of X has 28 elements, N of Y has 32 elements. So N of X is 28 plus 32 minus 50. So what is this equal to? 28 plus 32 is 60 minus 50. 60 minus 50 is equal to 10. So the number of elements which are common in X and Y, N of X intersection Y is 10. That's it. X intersection Y is 10. Same type problems. All these three problems are of same type. Okay. Hope you followed. Now let us come to the next problem. Same type problem. Okay. Now if S and T are two sets, S and T are two sets such that S has 21 elements and T has 32 elements and S intersection T has 11 elements. How many elements does S union T have? Same type problem. What is given here? Given that N of S, number of elements, two sets such that S has 21 elements and T, N of T, number of elements in T is 32 elements and number of elements X intersection T is equal to 11. How many elements does S union T has? Number of elements in S union T is to be determined. Same formula, number of elements S union T is equal to N of S plus N of T minus N of S intersection T. That's it. Substitute here. What is N of S? N of S is 21. N of T is 32 minus S intersection T is 11. So what is this equal to? Subtract this. First add 32 plus 21 is equal to 53 minus 11. That's equal to 53 minus 11 is 42. Number of elements in S union T. N of S union T is equal to 42. That's it. This is how we are going to solve this problem. Okay. So here these are few types of problems based on the union and the intersection. So this is one of the application of sets and the subsets. Okay, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.